All right, so looking at transformations of the linear lines, right away transformation means some sort of orientation or movement. And the transformations we're going to be looking at is translation, which is like a sliding movement, rotation, which can be clockwise or counterclockwise. So you are moving about a certain point in degrees, and then reflection, and that can be reflecting over a point or reflecting over the X or the Y axis. There's also dilation, which is enlargement. So just keep that in mind that we are not covering all of them, but we are looking at 3 of the 4. You'll be noticing again now that it says linear lines. What does that mean? Well, in order to be a linear function, it must have a positive, a negative slope, or no slope. In order to be a function, you wouldn't have the straight vertical line because it doesn't follow the vertical line test. It would hit too many spots. So a vertical line would not classify as a linear function. However, it would classify as a linear equation because you can produce a vertical line. The slope is just undefined. But for functions, again, we're only looking at the 3 cases. Keep in mind from yesterday's thing, in order for lines to be parallel, that slope must be the same. So you're going to be looking at the characteristics of the equations to help determine what type of function transformation is taking place. You're also going to hear the word parent function. That parent function just means it's the start, it's the original. You are taking technically this line and then moving it. So it's not 2 different lines. It's just saying if I were to have this line here and I moved it now over here, you'll have 2 lines on your graph, but it's just asking what did you do to this one line. So that's why it's given the parent function, and then they move in alphabetical order. So after F is letter G. After G is letter H. And then going back to what you guys have learned in previous years as far as the transformation was just a plot or a dot, when you guys ever had to reflect, you would just change the sign of the X if it was over the Y-axis. If you ever had to reflect over the X-axis, just talking a plot, so an ordered pair, then the Y, one of them would be positive, one of them would be negative, and it would look something like that. So the first one I want to look at today, moving past plots, is looking again at your linear lines, and that's translation. Translation is simply like a sliding movement. So if I were to give you the parent function, so the f of x, that's the same as y, it's just saying this is the parent. If I were to plug in the x value, what would you get for your y? The g of x is where you are doing your final movement. That's where you're having your transformation. So if I were to look at this, you're going to be given 2 equations, and the first thing it's going to say is to graph it. There are 2 ways to graph. You could find the slope. I see my slope is 2, and I don't see a b. That means that it starts at the origin. So you put your dot at the origin, and then you use the slope. Up 2 over 1, get a second dot. For a linear equation, you only need 2 plots to make a line, so then I can just draw my line. Otherwise, don't forget, you can always use your t-table. You have to know, looking at y equals mx plus b, b is always going to be your start point, so there's no b. That means it starts at the origin. That's where I got the 0, 0. Then you use your slope to figure out your next point. So the 2 goes on the rise side, so 0 plus 2 is 2, and then all whole numbers over 1, so then 0 plus 1 is 1. Now I have my next order pair, and I drew the line. Then this is saying that this whole line is going to move like that. It's going to be shifted. So it's like taking a piece of string and then sliding it, but we don't say sliding in math, we just say translating it over to this line here and letting the string go. So g of x is your transformation. So your line went from 2x to 2x minus 6. What do you notice about the slope? With translation, the slope doesn't change. In other words, they are going to be parallel lines. So no change in slope. That's the critical piece. but your b changes. So we went from 0 for my y-intercept here to my b is -6, which means my y-intercept is 0, -6. Then I use my slope again to find my next point. So -6 plus 2 gets me -4. 0 plus 1 gets me 1. My next point is at 1, 4. I plot it and I draw it. Then it will ask you, after you have graphed it, to describe or justify the transformation and classify. That's what I did here. So to justify, you are basically using what are you needing to memorize for this section. All right, well, looking at this graph, I noticed that my slopes are the same. There are 2 and 2. But the b went down. It went from 0 to -6. So this was a slide down. So the transformation graph should be an example of translation. So they're going to ask you to graph it, to describe it, and then to classify it. So the key thing for translation, you are going to look in the slope position. The slope should always be the same, but your b's change. In other words, you're having parallel lines. The next type of transformation is looking at rotation. So rotation is making something move at a certain point, and what you're going to notice is that the steepness is going to change. Well, what piece in an equation gives you the steepness? The slope. So that means the m position is going to change, and this time the point at which it hits the y-axis will not change. So what you're going to do is they're going to give you equations. Again, this is your parent one. This was the first move, and then yes, they can actually move it 3 times. So it's like saying, here's my parent function. I chose to now move it like this, and now I chose to move it like that. You tell me what I just did with that pen. So this pen is acting like the lines. So you graph the 3 lines, and then you look at the equation and kind of identify, what do you spot from this? You see all of them have a fixed point. They all intersect right at 0, 0. Okay, so that means that the solution or your intersect, moving into systems of equations, the next chapter, right there is where they would intersect in it. That means when you plug in 0, 0 into any of these equations, you get the same answer. But how do I know it's rotation? So you look at the equations, the parent function, the slope is 1, the parent function, the slope is 5, the parent function, the slope is 2. First thing that triggers in my head, slope changes. Okay, so that worked. Now let's go look at the b's. The b is 0, goes through the origin. The b is 0, goes through the origin. The b is 0, goes through the origin. Okay, it has the same y-intercept. Again, I got my 2 points and I graphed it. How would I describe this? The b's are the same, 0, 0, state where they are, but the slopes are different. That means that this type of transformation is known as rotation. Then you have reflection. So with reflection, you might be reflecting it over a point, but for this lesson here and for this chapter, you guys are really just going to be reflecting it over an axis. Basically, you're doing a mirrored image. It's like taking this pen, so this is my line. Actually, we'll start it here so it's following the parent. So this is my parent function, and I want you now to flip the pen over, and now it's here. So you're looking at reflection. With reflection, what you should notice is that the slope keeps the number, the value stays the same, but the sign changes. And the sign changes because you're moving quadrants each time. So in quadrant 1, if we started the parent function right here at positive, when you reflect it over the y, now you move it to quadrant 2. So now it becomes a negative. but your b, your y-intercept, stays the same. So all you're looking for is that the sign changes. In the instructions, they talk about it being multiplied by -1. Well, if you had, let's just say in your parent function, it started with a negative times a -1 would get it a positive. If you start with a positive and you times by -1, it gets a negative. So to me, that's just confusing students. Instead, just think in your head, these sign changes. From one of the parent one is either positive and negative, and the other one is the opposite. Bam, you're done. Reflection. How do we justify or describe when asked? B stays the same. That's your y-intercept. But the slope value stays the same, but the sign changed. In other words, the numerical, the number is the same, but it goes from positive to negative or negative to positive. All right, so when looking at your transformations, if you're given a problem, f of x equals 2x, that's your parent function, that's where your line is starting. Then they tell you that this line is going to move, which is g of x, and end up at 2x minus 6. So you need to describe this transformation, and then you would need to graph it on a coordinate plane. And I recommend that you either do different colors. Otherwise, to properly graph it, you should be putting these function equations on top of the line that is graphed. All right, so the first thing I'm going to do is I'm going to look at what's given. All linear lines are in y equals mx plus b. So right now, I'm going to look at the slope. And what I notice in the slope position, that's in the m position, I see 2 and I see 2. So I think, okay, slope stays the same. Both of them are 2, which means, remember, up 2, right 1. Then I'm going to go look at my y-intercept. Okay. My y-intercept for this, if it's blank, that just means it got eliminated. So that means it's at the point 0, 0. And this guy here is at 0, -6. So my y-intercepts change. All right, now I think of the 3 possibilities. So for translation, the slopes stay the same and the b changes. Okay, that means both of those were met. So since slope same, which is 2, but y-int changes, this would be a translation. So even without graphing it, even though it asks you to do that, you can simply solve these simply by looking at the equation. Again, if you were asked then to graph it, all you would do is use the information that is given. So if you're starting here, you know your start point is at the y-intercept, it's at 0, 0, and you're going to use your slope. So that's up 2, right 1. Okay, now that I have that, I just go ahead. You only need 2 points. Again, you draw your lines all the way through. And then you would just label it f of x, because this is the parent function, 2x. Then you come and you look at your g, which is where you moved it in the end. So that's the start line. And this time, I know it has to go through the y-intercept at 0, -6. So I'm going to make my dot here. And again, I'm going to use my slope to find the next point. You can go up 2, right 1. So up to you. You don't need to use a t-table. I wouldn't require it. You can just use your slope on your graph. Then when I see a graph line, I should see that these look parallel. And again, this function is identified by g equals 2x minus 6. So now my graph represents what I am mentioning and describing for number 1. Number 2, all right, look at the slope. What do you notice? So for my slopes here, I see a slope of 1 and 5. So these change. But now I'm going to go look at my y-intercept. My y-intercept for them is 0, so they both must go through 0, 0. Now you ask yourself, what transformation does the slope change, but the y-int remains the same? So when I'm looking at that, it's kind of like saying no, kind of like a clock. So if you're just changing that, then you are looking at, so the slope changes, but y-int the same. So this is rotation. Bam. And then again, if it does ask you to graph it, you would just graph it the same way I did the first problem. Number 3, f of x equals 2x plus 2. Graph, and then you need to reflect it across the y-axis. Write the function, then graph. Okay, what you need to do is you need to figure out what is the rule for when you're having to reflect. So when you have to reflect your work, what do you want to memorize? When you think of this, you just need to think that your slope sign changes, your y-intercept stays the same. All right, so let me write my parent function. F of x equals 2x plus 2. The slope sign changes. That's 2. That means that g of x must be negative 2x, and the b stays the same. Bam. Even without graphing it, you guys, I can identify it. Then all you would have to do is graph the 2 lines and prove to me that it is a reflection. So all of these problems can be done without graphing, which is definitely a higher level, and I want you guys to start memorizing what are the pieces in the equation that allow me to do that. Because then at this point, all you're doing is a t-table. And so if I were to do a t-table for the f of x, let's just say I didn't know how to graph it, I need to do a t-table. What you would do is your y-intercept is at 0, 2, your slope is 2, so plus 2, plus 1. My next point would be at 1, 4. Plot those. Now I have f of x done and can easily graph it. For g of x, same thing. I know my y-intercept is 0, 2. This time my slope is down 2, right? 1, 2 minus 2 is 0. 0 plus 1 is 1. That plot would be at 1, 0. So it's as easy as that. All right, let's look at a word problem. So Forrest charges $25 for a vase plus $4.50 for each flower. The total is represented by the function f of x is $4.50 times x plus 25. How will the graph change if the base cost is raised to 35? And then how would it change if the charge per flower is lowered to $3? Well, they gave you the function. They were actually very nice, but let's just assume they didn't. Even without giving the function, you guys should have been able to come up with that. And how do you do that? You look at your given. So wherever they mention a flat rate, so if you wanted to sign up for a gym membership, you have to pay $50 up front and then a monthly fee. Find where that flat startup rate is. So the startup thing just to buy a vase is going to be $25. That gives you your B. Your slope or your rate is how much per or each. That's something that means multiply times the input. So I spotted 450 times what? times the flowers. We don't know how many flowers. So right there, I was able to figure out the 450 is the slope times X is the flowers plus your flat rate. All right. So the first one says, how will the graph change if the base cost is raised to $35? The base cost is your B. So for question A, we're just going to label this as question A. If you were to go from f of x equals $4.50 plus 25 to, yes, you need to show this so that you're understanding a parent function versus the transformation, to g of x equals $4.50 per flower, but this time you're paying $35 for the vase. Now you have to say the slope stays the same. The slope stays the same, but the B changes. Okay? So if their slope staying the same, but the B changes, this right here would be a translation. And then if it asked you to graph it again, you would just graph these two lines. This time, it's going to ask you to change the cost per flower is lowered to $3. I don't mind if you just put 3 or 3.00. It's fine. But this time, you're still the 25. So they just changed it $3. All right. If you were to spot that, what tells you the slope changed? Slope changed from 450 to 3, but the B stayed the same. So if your slope changes, but your B stays the same, that is rotation. All right, so then if you're given the problem, graph f of x is x and g of x is 2x minus 3, then describe the transformations. The second you saw that, okay, transformations, that means they are telling you that two things happened. And it's going to help because what you're going to do is you're going to look first, let's look at the slope. Okay, the slope. Well, the slope went from 1 to 2, so this one changed. All right, now let's look at the y-intercept. Oh, the y-intercept went from 0 to -3. It changed. Well, according to all of our options, it doesn't fall under any of them, because with the same slope, you're looking at translation, okay? With the same slope, but having it a different sign, you're looking at the reflection. And then as far as rotation, your B should be the same, but they're not. So now you have to do process of elimination. So you heard me mention that with reflection, your slope signs should change. Do you see any change, or are they both still positive? So we notice they are both positive. That means that there's no way that reflection could have taken place with this. All right, so now let's see what would happen with the other ones. If the slope changed, which one says the slope changed? Rotation. So rotation must have occurred with this. And when you rotated it, what else happened here? Rotation, and then now look at your B's. If the B's change, but your slopes were to, let's just say, move down, and then all of a sudden they had to change the slope, what happened there? So we had to rotate it, and we had to How do you get from 0 to negative 3? Move down 3 units. Translation. So with the combos, you check the slope, you check the y-intercept. If both of them don't work, then you need to go and look at the slope sign so that you can see, all right, are we dealing with the reflection? Nope. Okay, now we know that both things change, which means you had to do both of these. What did you do? Well, when you sit there and you rotate, the y doesn't change. So in order to change the slope, we had to rotate at 0, 0. So first, what I did was I took this line and I rotated it. So that's why it stayed the same. But then all of a sudden, the b's changed. So you go in order of the equation. So right here, all right, we rotated. Now we go from 0 to negative 3. That means we